Hi, everybody. This is Dr. Niger with the Chem Calculations screencast. This screencast is going to look at naming and formula writing rules for ionic compounds. If you're looking for the rules for covalent compounds, organic compounds, acids, or the hydrates, please make sure you check for those screencasts. Okay, so we're going to start with a definition of ionic compounds. All right, so remember, when we were talking about how to differentiate the different compounds, ionic compounds are easy to spot because they are composed of two very different types of elements, specifically the metals and non-metals. All right, so if you're looking at the name of a compound and you recognize a metal, or the formula and you recognize a metal, then the chances are you have an ionic compound. Now we'll learn later that hydrates are a special class of ionic compounds, so you'll see metals there as well. All right, so what is an ionic compound? Well, in an ionic compound, electrons are transferred between the atoms. Particularly metals transfer electrons to non-metals. Okay, so that means in general, atoms become ions. All right, so our metal is donating the electron, so it loses an electron, and our non-metal accepts that electron. So when the metal loses something that's negatively charged, the metal atom becomes an ion that is positively charged, which we call a cation. The nonmetal, by accepting that negatively charged electron, becomes negatively charged, and that's our anion. All right. When ionic compounds form after the electrons are transferred, it's the charges that are opposite that are attracted to one another. And that attraction is what forms the ionic bond and then the ionic formula unit. All right. So when we're ready to name, there are a couple tools that you need. So tools needed for this process. All right. The first thing you always need is a periodic table. All right. We're going to talk about the elements in just a second, but the periodic table, you need it for the charges for those metals and non-metals. All right. So always make sure you have a periodic table handy. Second, all right, you must know your polyatomic ions. All right. And that means you need to know their names, you need to know their formulas, and you need to know their charges. Okay, so we have a couple that we ask you guys to memorize because they're the most common ones. And so knowing them makes naming and formula writing easier and it makes it faster. But there are many polyatomics out there, and there could be an ion that you haven't heard of, and you can just look that up on Google. All right, but for now, the ones we've asked you to learn, you need to know. All right, and then three, you need to ID your multivalent metals. All right. The main group metals, which are in group 1, 2, and 13, are called monovalent metals. They take one charge. They only donate one amount of electrons, and that's it. So the ions that they form are always going to be the same. The transition metals in the middle of the table, and a couple that are underneath the staircase over in the main group part, are called multivalent metals. That means that they're able to transfer different amounts of electrons. So maybe in one instance they transfer two, and a different they transfer three, or maybe they transfer one, or they transfer two, or they transfer two, or they transfer four. All right. So if they're able to do that, they fall under this category of multivalent metals. So we need to recognize when our compound, or our formula unit rather, has a multivalent metal in it. All right. We also need to remember the crisscross rule. All right, now the crisscross rule is what lets us determine what the subscript should be in our formula unit for our ionic compound. And then finally, we need to remember that ionic compounds are neutral. All right, they are formed of ions, but those ions interact with each other in such a way that you have a balance of charge within that formula unit. Okay, so before we go to the rules, I want to take a minute to look at the periodic table because I think it's important for ionic compounds, specifically acids, it's useful too. But you need to recognize how to use the table to determine the charges of your monovalent ions. All right, so I have a periodic table down here. All right, first off, remember the majority of the table is made up of metals. They are to the left. And then in the upper right corner are going to be your non-metals. All right, there are semi-metals on the table. Generally speaking, if they're on that staircase, they are considered a semi-metal. All right. If they are above the staircase, like boron, silicon, arsenic, tellurium, and astatine, they're going to behave like your non-metals. So you're not going to see these guys in ionic compounds. They tend to form covalent compounds instead. All right. If you see germanium, antimony, and polonium, those are below the staircase. They do tend to act a little bit more like the metals. So you might see them in some ionic compounds, particularly germanium and antimony. Okay. Now, we have main group elements, and those main group elements are in groups 1, 2, and then 13, 14, 15, 16, 17, and 18. Those are considered the main group elements. In group 1, these metals, lithium through francium, always take a +1 charge. All right. In group 2, which is beryllium through radium, they take a +2 charge. In group 3, we're really going to focus on aluminum. Let me change that color. Hold on. Aluminum and gallium. They're in group 13. They take a +3 charge. All right, now I'm skimming over some of the details, but this all has to do with the octet rule and the number of valence electrons these elements have. All right, as we continue to move across the table, now we're in carbon's group. Carbon and silicon tend to stick with covalent molecules. They have 4 valence electrons and they want 8. So they could either pick up 4 or lose 4. And energetically, it's hard for them to decide. So instead, they just share electrons in covalent molecules. All right. But once we get to group 15 with nitrogen, then we've got some true nonmetals that would like to accept some electrons. So this group is going to form -3 ions. All right. Then oxygen, sulfur, and selenium in the next group are going to form -2 ions. And then the halogens, fluorine, chlorine, bromine, and iodine, are going to form -1 ions. All right. So if we're talking about the main group elements, these are our monovalent ions. Group 1 likes to form +1 ions. Group 2 likes to form +2 ions. And group 13 likes to form +3 ions. And these are all going to be our metals. All right. Group 15 likes to form -3 ions, group 16 -2 ions, and then group 17 -1. And these, our anions, are all our non-metals. Okay, so these are all going to be our monovalent. All right, so single charge option for these guys. All right, now what we've got is the middle of the table. All right, so this piece of the periodic table. All right. This part of the table is known as the transition metals. And this is where a lot of our multivalent metals reside. So it's not as easy as knowing what group they are in to know the charge. So you're not going to be able to do that like you can with the main group elements. Instead, there has to be a clue for you. Either you know the formula and you can use the formula and the idea that the molecule has to be neutral to figure out what the charge is on the metal, or the name is going to have a Roman numeral in it, and that Roman numeral tells you the charge. All right, so we'll be looking at that when we get to those naming rules. I do want to point out 3 metals in here, and it's zinc, cadmium, and silver. All right, these 3 metals in the transition group are monovalent. So they only have one charge option, and you need to know what it is because you can't just tell from looking at the table. All right, so silver always forms a +1 ion, zinc always forms a +2 ion, and cadmium always forms a +2 ion. So those 3 you're just going to have to know. Okay? All right, so let's move back up to the top and work on these naming rules. All right? So at first, we're going to figure out the formula from the name. Okay, so we've identified our compound as an ionic compound. All right, so we're now going to use these rules. All right, you have to be careful. All right, you must watch the details when you name and formula right. Whoops. All right, you have to know charges and those polyatomic ions. All right, if you don't, you are going to make mistakes. Naming and formula writing is not something that you can just pick up the day before. It is something you have to practice. All right, I just want to also take a moment to talk about that crisscross rule. All right, the crisscross rule tells us that the charge on one ion is the subscript on the other ion. All right, so what does that look like? Well, let's take NaCl. All right, so I know that sodium's in group 1, so it gets a +1 charge. Chlorine is a halogen over in group 17, so it's -1. So the 1 for chlorine becomes the subscript for sodium, and the 1 from sodium becomes the subscript for chlorine. Now, when you write formulas, you don't actually list the 1. So the correct way to write this formula is NaCl. It's understood that if there's no subscript written, that it is a 1. All right, so that's the crisscross rule. We're going to be using that for every single one. All right, so how do we know what to do? All right, so we've got our name, and we're reading it, and the first element is a metal, so we know it's ionic, and there is no Roman numerals, so without a Roman numeral. So the first thing you're going to write is the metal with its charge, the symbol of the metal with its charge. All right, and then you're going to write the formula of the second part. Now the second part is the non-metal portion. It's probably going to end in either IDE, ITE, or ATE. If it ends in ITE or ATE, it is one of your polyatomics. If it ends in IDE, it is most likely an element from the periodic table, with two exceptions, cyanide and hydroxide. Those are polyatomics that end in IDE. All right. So once you have your symbol and your charge, then you're going to crisscross those and take the charge and make it the subscript of the other ion, and then vice versa. And then you are going to write the formula metal first, non-metal portion second. When you're finished, you need to look at those subscripts, and they must be the smallest possible subscripts. So if you finish and you have a subscript of 2 for one element and a subscript of 2 for the other element, those can both be reduced to ones. So you should rewrite the formula with ones. Okay? All right, now what if instead we're reading the name and there's a Roman numeral present? All right, now you can see that there's this classical name. We are not doing that this year, so I'm going to just mark that out. We'll just ignore that. All right, if there's a Roman numeral, that's telling you you have one of those multivalent metals. And the Roman numeral is the charge on the metal. All right, so if the Roman numeral is 2, then that metal has a +2 charge. If the Roman numeral is 4, then it has a +4 charge. So the Roman numeral's job is to tell you what the charge is on that particular metal. And then we're going to repeat exactly what we did on the other side. We're going to write the metal with its charge, and then we're going to write the non-metal portion with its charge, crisscross those charges, and rewrite the formula. Again, making sure that we have the lowest set of subscripts possible. All right. Again, just ignore this classical name stuff. You guys will be happy we're not doing that. It gets confusing. Okay. All right. Don't forget that you just need to know silver, zinc, and cadmium. There will be no Roman numeral with those metals in the names. Okay, so let's do a couple. All right, first, aluminum fluoride. So aluminum, Al, is in group 13, so it's +3. Fluorine is in group 17. It's a halogen, it's -1. So we're going to cross those charges and our formula will be AlF3. That's the lowest set of common subscripts, so we're all set. All right, we're going to move on to iron 3 nitride. So you can see we have a Roman numeral here, and that Roman numeral is the charge on the iron. So Fe+3 nitride, that IDE tells me that this is nitrogen, which is -3. All right, so when I write my formula, I'm going to write Fe3N3, but that's not the simplest version. So I need to reduce those subscripts to Fe N. All right. So we've got FEN. All right. I should back up. We should be checking these to make sure that they are neutral when we're finished. All right. So iron is +3, nitrogen's -3. So that gives us a neutral molecule. So we know that's a good formula. All right, magnesium nitrate. So Mg, it's in group 2, so it's a +2 metal. Nitrate, that ATE tells me that's one of my polyatomics, in this case NO3 with a -1. So we're going to cross the charges. All right, so magnesium, I only need one of those, but I need 2 nitrates. So I need a set of parentheses here. And I put the nitrate in the parentheses and the 2 on the outside so that I recognize it's not just 32 oxygens, it's 2 nitrate groups. All right, so we'll have a +2 charge here, 2 times -1 here, so we're going to have a neutral molecule. All right, we have chromium 2 cyanide. So again, we've got this Roman numeral. All right, and that Roman numeral is telling us the charge on that chromium. So Cr+2 cyanide. So I'm like, okay, is that a single element? But there's no cyano anything on the periodic table. So this is a polyatomic as well. Cn-1. Cross those charges. So we're going to have chromium cyanide with a 2 on the outside. All right, +2 for that chromium, 2 times -1 for the 2 cyanides, and we have a neutral molecule. All right, silver perchlorate. Now, silver is one of the transition metals that we just have to know. All right, and it is always +1. Perchlorate. All right. So this is one of those polyatomics that we need to know. All right. And this is ClO4 with a -1 charge. So we're going to cross those charges and we get AgClO4. All right. +1 for the silver, -1 for the perchlorate, neutral molecule. All right. We move on to the next compound. Now, this one's a little tricky, right? Ammonium. All right, so I don't know any metals called ammonium, and that's because this is another one of our polyatomics. All right, this polyatomic is the only cation polyatomic, and it's NH4 plus. All right, hydroxide, that IDE. I go look on the table. There's no element that's going to fit that. Instead, that's another polyatomic, so it's OH minus. All right, so we're going to cross our charges, and we form, oops, NH4O. H, all right? +1 for the ammonium, -1 for the hydroxide. So that is a neutral molecule. All right, we move on down. Again, we've got a Roman numeral, and that Roman numeral's job is to tell me the charge on that tin. All right, tin is Sn and it's +4 according to the formula. Oxide, that's oxygen. Oxygen's in group 16, so it's a -2 charge. So I'm going to form a compound that has a formula SN2O4. All right, but that can be reduced. The 2 and the 4 can both be divided by 2, and we get a formula of SNO2. All right, and if we look, +4 for that 10, 2 times -2. So that is a neutral molecule. So that is a reduced formula. Make sure you watch out for those. All right, up next, we've got copper 1 oxalate. So that's the charge on the copper is +1. Oxalate, that ATE tells me that that is a polyatomic. And in this case, C2O4, it's a -2 charge. So we're going to cross those charges and we have Cu2 C2O4. Now, here, you have to be careful. It is super tempting to just take all those subscripts and convert them to CuCO2. The problem with that is the C2O4 is a polyatomic ion. If you change that to CO2, it becomes carbon dioxide, which is a very different animal. So you cannot, in this instant, change those subscripts. You have to leave that one alone. All right, so just be careful. All right, and then last we have calcium phosphate. So calcium is +2, phosphate, so a polyatomic PO4 with a -3 charge. Cross those charges. We're going to have Ca3 parentheses PO4 with a 2 on the outside. So 3 times +2 and then 2 times -3 is going to give us a neutral molecule. Okay, so again, it's all about knowing those charges and using the crisscross rule. If you don't know the polyatomics, it can be really tough. If you don't know how to use the periodic table for the charges, it can be really tough. If you don't recognize what the Roman numerals telling you in the name, it can be really tough. Naming and formula writing just takes practice. If you practice, you will get it, I promise. All right, now for the other way, which I actually think is easier, if you're given the formula and you're asked to write the name. All right, so again, we're going to split the metal into the two groups. The metal has only one possible charge, or is the cation NH4 plus 1. All right, if that's the case, you're going to look at the formula and you're going to name the metal first, or ammonium. But if it's a metal, just its elemental name. So sodium or aluminum or potassium. All right. The second half of the name is going to be the non-metal portion. If the anion is an element, then you take the root of that element's name and you add an IDE ending. So fluorine becomes fluoride, chlorine becomes chloride, nitrogen becomes nitride, sulfur becomes sulfide. So you're taking the root of their name and dropping the ending and swapping it for IDE. If the anion instead is one of your polyatomic ions, you just use the name as is. So if it's nitrate, you just write nitrate. If it's phosphate, you just write phosphate. You don't change anything about the polyatomics names. All right. If instead you have a particular metal that has 2 or more possible charges, so these are our multivalent metals, the first thing you have to do is figure out what the charge is on this metal. All right. You can reverse the crisscross. I think that is the easiest way to do it, but you have to watch out for these already simplified formulas. All right. Once you know what the charge is, then you're going to just name the metal and use a Roman numeral in parentheses after that metal name to indicate that charge. So if you determine that's copper and it's a +2 ion of copper, you would say copper, Roman numeral 2. All right. If it's lead and you determine it's a +4 ion of lead, you would write lead, Roman numeral 4. All right. Now, just as a reminder, because not everybody knows Roman numerals anymore, I'll just give you a couple. We usually only have 1, which is 1, 2, which is 2, 3, which is 3, and it's this one that always messes everybody up. All right. We won't see any multivalent metals with charges higher than 4 in this class. All right. In the end, for all of this, you need to use the periodic table and your brain. All right. So make sure you know those polyatomics and you recognize where the metals are. All right. Don't forget about the transition metals with only one charge. All right. So that is silver, zinc, and cadmium. Whoops. Calcium, cadmium. All right. No Roman numerals. No Roman numerals. No, 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 no. All right. And again, we're not doing the classical name stuff, so you can just ignore that. Okay, so let's do a couple just to practice. All right, we start with the first part, Ag. All right, so that is silver. Now it's a transition metal, but it's not one of the multivalent, so no Roman numeral. And this part is a polyatomic. And I know because I practiced that is permanganate. Now there's an extra permanganate. Everybody wants to drop that middle "an" part. All right, so silver permanganate. All right, now we're going to go over to this next one. Now, nickel, if I look on the periodic table, is in the transition block, and it's not one of the 3 that has a single charge. So this is going to need a Roman numeral. All right, so I'm going to try by reversing the crisscross. All right, so if I needed a subscript of 2 for my nonmetal portion, then that nickel must have had a +2 charge. So that's what we mean by reverse the crisscross. All right. On the other side, I have BrO3, which has a -1 charge. So that makes sense that I'm going to need 2 of those bromates. All right, so the name is going to be nickel, Roman numeral 2, and then bromate. Okay. All right, up next, we have SN2. All right, so SN is 10. So I go look, the periodic table has it not in the transition block, but underneath the staircase. So there are a couple under there that also are multivalent. Tin is one of them, so is lead, antimony sometimes. All right, so we need a Roman numeral for this one. All right, so I'm going to reverse this crisscross. So that makes me think it's 10 +2, but if I reverse the crisscross for sulfur, it tells me sulfur is +1. All right. So I know that sulfur is in the same group as oxygen, and oxygen is always -2. So this charge for sulfur, this is incorrect. What that tells me is this formula has been simplified. All right. It was originally SN2S4, but it got simplified to SNS2. So this is the one I need to reverse the crisscross for. All right. So it's not 10 +2, it's 10 +4. All right. It's not sulfur -1, it's sulfur -2. And that is the correct charge for sulfur. So I know that I have done the correct charges for these guys. All right, so then I write the name 10, Roman numeral 4, and this is sulfur and it becomes sulfide with that IDE ending. All right, up next we've got lithium. That is a main group element, so it's just written as is. And then this next group, the C2H3O2, that's a polyatomic, which is acetate. So lithium acetate. All right, here I have lead. Lead is a multivalent option, so it's going to need a crisscross. All right, so this reverse tells me lead is +4 and that HCO3 is -1. All right, because I know my polyatomics, I know that that is the correct charge for HCO3, so I don't need to do anything else. This is a good formula as is. So lead 4, and this second piece is bicarbonate. All right. Up next, I've got cadmium and chromate. Cadmium, again, it is in the transition block, but one of the ones that does not have more than one charge. So I just write cadmium, no Roman numeral needed, and CrO4 is chromate. All right. Next, BAS. So BA is barium. That is in group 2. So that does not need a Roman numeral, followed by S, which stands in for sulfur. So that becomes sulfide. So that's barium sulfide. All right, now we have chromium. Chromium is one of the multivalent metals. So I'm going to reverse my crisscross and I end up with Cr +2 OH -1. So I check that anion. Hydroxide is -1, so nothing has been simplified. So this is chromium 2 hydroxide. All right, and then last but not least, KNO3. K is potassium. That's a group 1 metal, so only one option, so no Roman numeral. And that NO3 group is nitrate. So this is potassium nitrate. Okay, so again, I want to really emphasize this portion right here. All right. You need to be very careful when you go from the formula to the name for these multivalent ones, because if it has been simplified, you are going to put the wrong Roman numeral in. So please check the anion. You're going to know what the charge should be on the anion. There's no question for that. You either know because you know where it is on the periodic table, group 15, 16, or 17, or you know because it's a polyatomic ion. If when you reverse the crisscross, it doesn't have the right charge, the formula has been simplified and you need to fix it before you write the Roman numeral. Okay? Again, Practice, practice, practice. All right. If you have any questions, please let me know.